Okay, we will go through the exemplar questions in class 12 chemistry chapter 10 HaloAlkanes and HaloArenes. Okay, so before going through it, we will see some basic information. Hmm, HaloAlkanes, that is alkyl halide, HaloArenes, that is aryl halides. Okay. So, what is this primary carbon atom? Okay, primary is represented by this 1 degree. So, this carbon atom, the group connected to the carbon atom, this carbon atom is connected to the only one carbon atom. Okay, here, so suppose let us say Cl is connected to this carbon, this is having connection with only one carbon atom. This is the primary carbon. Okay, here this is secondary carbon. This carbon having connection with bonding with two carbon atoms. Okay, this is secondary carbon atom bond with two carbon atoms. This similarly tertiary carbon atom. This carbon atoms have a bonds with three carbon atoms. 1, 2, 3. Okay, now this alkyl halides, they have the general formula CnH2n plus 1. Okay, that means if you say n equal to 2, that means C2H5. Okay, in this bond carbon halide halogen bond, carbon have partial positive and this halogen atoms have a partial negative. So the halogen atom have more electronegative than the carbon atom. Electrophile means it is electron lovers. Okay, it loves electron, that means it is a positively charged. Okay, example Cl plus. Okay, so it is a electron lover, it attacks electron rich elements. Okay, wherever more electrons are, it attacks, accepts the electrons, that is can accept, that is electron lovers. This is a Lewis acid. So you have nucleophile, it loves nucleus, that means it is a negatively charged one, say Lewis base, and it is electron rich, donates electrons. Okay, now this compound is a benzyl chloride. Okay, benzyl chloride, X is a like assume is a chlorine. Okay, it's called benzyl chloride, but this is, if we say this chlorobenzene. Okay, this is a chlorobenzene. If you say X is Cl, then it's a chlorobenzene. So it is directly connected to the benzyl ring, that is aryl halide, but this halogen atom is connected through the methyl group, so that is a benzyl halide. Now what is carbocation? Carbocation. Cation means is ion with a positive charge, carbon with a positive charge. Here is that example. So sp3 hybridization means carbon is connected to 4. This carbon has 4 valence electrons. So all are connected with a single bond. So let's say this is hydrogen. Okay. So all 4 bonds with a single bond, all sigma bonds. sp2, it has a double bond, that is this double bond 1 sigma and 1 pi. These are all sigma bond. This is sp2 hybridization. Okay, double bond. There is a Markovnikov rules. Okay, for alkenes. Okay, see this is this alkene is unsymmetrical. This is in the double bond, this is unsymmetrical. Right side CH2, left side we have CH3CH. Okay, this is unsymmetrical. It reacts with this hydrogen halide, general halide. Okay, here iodine is there, so it forms these two compounds. So which side of the double bond this iodine will attack? Okay, this is what they given by the Markovnikov's rule. So he says with the less number of it attacks at the less number of the hydrogen. Okay, so here this side have only one hydrogen, this side two, so it attacks here. So this is the major products. Actually this side, this iodine goes this side, left side of the double bond. So here, so this is the minor product. Okay, that is what is given by the Markovnikov's rule. Okay, there are difference between SN2 and SN1 reaction. SN2, this reaction occurs in only one step. The molecularity is 2, that means the rate depends on the concentration of the two reactions here. But here SN1, it occurs in 2 steps and the molecularity is 1, that means rate of this reaction depends on only one concentration of only one reactant. Okay, here this rate of C reaction is more in the primary halide. Like primary means is I already showed you primary carbonate. Primary is greater than the secondary, get tertiary, but here it is otherwise. SN1, tertiary greater than the secondary, greater than the primary. Here the carb cation is formed as an intermediate stage in the SN1. Here there is nothing in the intermediate stage. But in case of these halides, Ri, this reaction will be greater than this R, Br greater than this. This is applicable for both SN1 and SN2 reaction. Okay. Here, what is chiral and achiral? Okay, so here if you say this one bromobutane, this is achiral, that is symmetrical. Okay, so here we have 2 bromo butane. Okay, here we have 4 carbon atom is connected to 4 different atoms or group, so then it is called achiral. Okay, 4 different atoms or group is connected to the carbon atom, but here we have 2 hydrogen atoms, that is the same atoms. So this is symmetrical, this is asymmetrical, this is chiral and achiral element. Okay, here enantiomers, so this when this mirror image is not superimposable with the original, then it is called enantiomers. Then it is called one type is called chiral and other is achiral. Both are enantiomers. Okay, see, this is another example of the chiral molecule. There is one more rule, sits up, or it is pronounced as this also. So here if you take this molecule 2-bromopentene, when it reacts with OH, so which there will be a double bond will be formed, whether this right side of this bromine or left side of this bromine. Okay, here there are 2 products. One, this is 81% and this is 19%. Okay, this is minor and this is major. So which of this product will be formed, that is given by this rule. So it says there is more number of alkyl groups attached to the carbon atom. So here this carbon atom, we have more number of alkyl group attached. So this is the major product, 81%, this is 19%, and this rule is given by this person. Okay, so where that double bond is formed, here it is formed here. You see here this is double bond is formed on the rightmost carbon atom. So this is the major, so most of the time it will occur this. And this is generally dehydrogenation reactions or beta elimination reactions. Okay, formation of the bipond. In addition reaction, the pi bond will, that is double bond will be broken, but in this reaction double bond is formed. Okay. Okay. The order of the reactivity of the following alcohol with halogen acids is, okay, this is the tertiary is greater than, secondary is greater than the primary. Okay. Here, the order of the reactivity of the alcohols with the given halogen acid is tertiary is greater than the secondary is greater than the primary. So these are the alcohols. Which of the following alcohols will leave the corresponding alkyl chloride on reaction with the concentration at room temperature? They are asking at the room temperature. Okay, this is the one. Tertiary alcohol without using zinc chloride as a catalyst. Okay, at room temperature only this alkyl chloride will be formed. So here the reaction of the primary and secondary alcohols with the HCl require the presence of the catalyst zinc chloride. Okay, but for with the tertiary alcohols the reaction is conducted by simply shaking the alcohol with concentrated at room temperature without the catalyst for the tertiary alcohol. So this is the tertiary, that is carbon atoms connected to 3 carbon atoms here. Identify the compound Y in the following reaction. This is Sandmeyer's reaction. Okay. HX and CVX is involved in this. This is aryl halide. Okay. So this is the reaction. Okay. This amines, primary amines. This is the product formed on that reaction. So from this itself we can make out that is this Sandmeyer's reaction. So this is the aryl halide. Toluene reacts with the halogen in the presence of the ionic chlorine, giving ortho and para halo compounds. The reaction is electrophilic substitution reaction. Okay. Electrophilic substitution reaction. Toluene. Okay. So this is ortho and para. Halo. Okay, this is that reaction. Which of the following is the halogen exchange reaction? Okay, here halogen is exchanged, or X, this X will be replaced by these halogen atoms. Okay. This is the halogen exchange reaction. This is also called this single chain reaction. Okay, here this is that reaction. Which reagent will you use for the following reaction? Okay, this is free radical halogenation 7. Okay, this is light. So this is free radical halogenation. Free radical halogenation. This is that reaction. Okay, this here also is written. Arrange the following compounds in the increasing order of their densities. Okay, densities. The density bromide having greater than the chlorine. 11. The density increases with increase in number of carbon atoms. Okay, number of carbon atoms. Okay, number of carbon atoms is same here, but we have to consider the other elements also. Number of carbon atoms, halogen atoms, and atomic mass of the halogen atoms. Okay, here actually atomic mass is determining the this one is the more density among the okay, because bromine is having more atomic mass than the chlorine. Here two chlorine atoms we have, but here we have one bromine. Arrange the following compounds in the increasing order of their boiling point. Boiling point. Less boiling point when more branches for the same molecular formula. These are all having the same molecular formula, but this have more branches. So this will have the less boiling point. C is less than A, and more this have the more highest boiling point in this because there is no branch here. Boiling point. The boiling point of the isomery decreases with the increase in branching. More branch means the boiling point will decrease. In which of the following molecules carbon atoms marked with asterisk is asymmetric? Asymmetric. Okay. Carbon attached to the 4 different atoms or groups. 4 different atoms are the groups. So here we have here we have 2 same atoms. So this is not asymmetric. All the 3 are asymmetric here. We have 4 different atoms and groups attached to the carbon atom. Which of the following structures is enantiomers? Okay, this mirror image is not superimposable with the original image. This mirror image of this will not be superimposed. Enantiomers, non-superimposable mirror images. So here this is not superimposable. This mirror image of this is not superimposable with this. Okay, the other things are not mirror images of A. Okay. The stereoisomers related to each other, non-superimposable mirror image is called enantiomers. Okay, so here you see these two are enantiomers. They are although they are chiral, they are chiral. These two are enantiomers. They are chiral. Enantiomers can be a chiral and a chiral. So when two are mirror image is not superimposable, then it is enantiomer. Question number 11. Which of the following is an example of this dihalide? Okay, halogens bonded to the adjacent carbon atoms. Okay. So here halogen is connected to the adjacent carbon atoms. Okay. The position of the Er in this compound can be classified as Er is adjacent to the carbon atom which has a double bond. So these are the compounds in which halogen atoms is bonded to an sp is bonded to an this sp3 hybridized carbon atom adjacent to a carbon-carbon double bond. So here carbon-iron double bond is there, then adjacent to that is connected halogen. Carbon-iron double bond adjacent to that carbon atom, halogen atom is connected. Okay. Chlorobenzene is formed by the reaction of the chlorine with the benzene ring in the presence of this is AlCl. Which of the following species attacks the benzene ring in the reaction? Okay, this is the electrophile, that is it has the electrophile, it attacks, it has the more electrons, so attacks the electron rich benzene ring. Electron rich benzene ring, this electrophile loves the electrons, that means that benzene ring will have the more electron. Okay, ethylene chloride is an two halogen atoms connected to the same carbon atom. Two halogen atoms, they are connected to the same carbon atom here. Okay, this is the compound. What is A in the following reaction? Okay, this is asymmetrical in the from the double bond. So this add HCl, so which side it will attack? Okay, this is given by the Markovnikov rule. So which side has the less number of the hydrogen atom connected to the carbon? So this side, this is the major product. So this side, left side of the double bond, these halogen atoms is bonded. Okay, Cl ion attacks the double bond with the carbon atom which has less number of the hydrogen. Okay, this side has the less number of hydrogen, that is given by this rule. A primary alkyl halide would prefer to undergo primary SN2 OT, primary alkyl halide. So here simple alkyl halides react rapidly with the SN2 reactions. Which of the following alkyl halides will undergo SN1 reaction? So I already shown you. Already shown SN1 SN2. Okay, so here if you see for a given alkyl group, the reaction of the halide, it will prefer the iodine first within the halide group. So here within this halide, so iodine will be most reactive. Which is the correct IUPAC name for this? Okay, this 1-bromo-2-methyl. What should be the correct IUPAC name for this? Okay, you can go through this IUPAC nomenclature. The reaction of the toluene with the chlorine in the presence of the ion and in the absence of the light yields. So this is the toluene. Okay, here in the presence of light we have a ortho and a meta product. Allotoluene, okay, ortho para allotoluenes. Mixture of these two, that is ortho and para. Chloromethane and treatment with the excess of ammonia yields this one. Okay, molecules whose mirror images are non-superimposable over them are known as chiral molecules. So which of the following molecules are chiral in nature? Okay, 2-bromobutene. Okay, what is chiral and achiral? Okay, these are all non-superimposable. They are chiral molecule. This is superimposable. Okay. These are all chiral, and these is chiral molecules. The reaction of this bromine with aqueous sodium hydroxide follows SN1 mechanism. Carbocation is stabilized by resonance of this benzene ring. Okay. The carbocation the formed is stabilized through the resonance when I have the benzene ring. Okay. This, which of the carbon atom presents in this molecule given below are asymmetric. Asymmetric is connected to 4 different groups. Okay, this connected to different groups. So B and C. They are the chiral carbon atoms. Which of the following compounds given racemic features are this nucleophilic substitution by OH ion? So this one A. Page 19. A mixture containing 2 enantiomers in equal proportions will have a zero optical rotation, so such a thing is a mixture. Okay. In the question 26, arrange the following among the rate of the reaction towards nucleophilic substitution. This is ortho. NO2 electron withdrawing groups in the ortho and para increases the reactivity. 24. The presence of the electron withdrawing group at the ortho and the para positions increases the reactivity. Okay. The CH3 is the electron releasing group at the ortho para position decreases the nucleophilic substitution reaction. So this is opposite to this. Okay, this is the electron withdrawing group, then electron releasing group. Okay, here this is ortho, this electron withdrawing group. So this is having more reactivity than this and then this. Electron releasing group. Which is the correct increasing order of the boiling points of the following compounds? So halides with hydrocarbons. Okay. Within the halides, iodine is the highest. So we have here halides. So this is the hydrocarbon without halide. So this will have the more within the halides. This iodine will have the more boiling point. 10. So iodine will have the more boiling point. Intermolecular process, the halogen derivatives. That is why the boiling point of chlorides, bromides, halides considerably higher than that of the hydrocarbons. Okay, halides have more boiling point than hydrogen. Within the halide, iodine has the highest. Which is the correct order of the boiling point? So here we have ethane, propane. So the more carbon atoms have the more boiling point here. So all having bromine. So which has the more. So that is the highest boiling point. Multiple choice questions. In the following question, 2 or more choices may be correct, and the following answer will be 32, 34. Which of the statements are correct of the above reaction? Okay. This is the reaction. So here A and Z are both nucleophiles. That means it loves the nucleus. That means this is electron rich. Nucleophile is electron rich. That is why it loves the nucleus, which is of positive. Now is sp hybridization. In C, okay, there is a double bond here. Only, so this is unstable. Sorry. So here A and C both are nucleophiles. C is the and C carbon atom is sp2 hybridized. That is the intermediate stage. Which of the following statements are correct about this reaction? The given reaction is a one step, that is NCERT reaction. It depends on the concentration of the both this and this, A and B. BD have the opposite configuration. OH and the other side of the area, B and D. B and D, okay. This side and the back side, hydroxyl ion attacks on the back side. Which of the following statements are correct about the reaction intermediate? Intermediate is unstable, okay, yeah, because of the carbon is attached to the 5 atoms. Intermediate is less stable than the reactant B, yes, that is unstable. This one is unstable. Which of the following statement correct about the reaction? A carbocation will be formed as an intermediate stage in this reaction. Okay, this is SN1 reaction, so there is a carbocation is formed. Reaction proceeds the SN1 mechanism is. Which of the following statement about the kinetics of the rate of reaction depends on the concentration of only B? Okay, yes, only one. Molecularity is 1 for the SN1 reaction. Concentration of this only. Molecularity is 1, yes. Molecular participant reaction. HaloAlkanes contains halogenations attached to the sp3 hybridized carbon atoms in the alkyl group. Okay. Identify the HaloAlkanes from the following compounds: 2-bromobentane, trichloroethane. Ethylene chloride and ethylene chloride are the isomers. Identify the correct statements. Both the compounds form the same product on treatment with the alcohols. Okay, both the compounds form the same product on reduction. Which of the following compounds are the, this I already shown you. 4. Okay, these compounds I already shown you. Which of the following are the secondary bromides? That is, secondary means bromide is connected to the carbon atoms, which is connected to the 2 other carbon atoms. Okay, here you see what is primary, secondary, and they are given. Okay. Which of the following compounds can be classified as RL halides? RL3. RL halides, okay, they are directly connected to the benzene ring. These are the compounds they are directly connected to the sp2 hybridized of the carbon atom of the aromatic ring. Alkyl halides are prepared from alcohol by treating with these two. Okay, here they are given. Alkyl fluorides are synthesized by heating the alkyl chloride bromide in the presence of this Schwarz reaction. Okay, this one. Short answer type. HaloAlkanes bromide can be easily prepared by the electrolytic substitution of the reactions because of, but the what are the preparation of the aryl iodides require the presence of the an oxidizing agent. Reactions with iodine are reversible in nature and require the presence of the oxidizing agent. Okay. Presence of the oxidizing agent. Iodination reactions are reversible in nature. To carry out the reaction in the forward reaction, HAir formed during the iodination is removed by oxidation. So is used as the oxidizing agent. Okay. Out of orthopyro dibromobenzene, which are the higher melting point Y. This is the higher melting point because of this answer. Okay. Crystal lattice. Which of the following concern faster in SN1 reaction with OH ion? Okay, faster in SN1. Then SN1, SN2 difference I already shown you. So 60. This one. This show high reactivity. Okay, lytic and benzylic halides. Benzylic halides have the higher reaction. Why iodoform has appreciate antiseptic property? Due to the evolution of this free iodine. Iodoform. Okay, you can go through this. HaloArenes are less reactive than HaloAlkanes. Okay, and HaloAlkanes explain double bonds due to the double bond bulky nature. Lewis acid. Role of the Lewis acid in the preparation of the aryl bromides and chloride in the dark. This is the Lewis acid as a catalyst. Which of the following compounds A and B will not react with the mixture of NaBH2Y? The CO bond is more stable, okay, because of the resonance. This is having the resonance. Which of the products will be the major products in the reaction given below? Explain. So this is again this rule. This have the less number of hydrogen atom attached to this side of the carbon. Okay, this will join here. Okay, this is the major product. Major products of the explanation. This is Marconi-Cauchy rule. Why is the solubility of the haloalkanes in water is very low? 11. Very slightly soluble in water. In order to dissolve in water, energy is required. Okay, you can go through this answer. Draw the other resonance structures related to the following structure. This is a molecule in orthopera. Okay, these are this resonance structure, other resonance structures. The electron density increases in the ortho more at the ortho and para position than at the meta position. Classify the following compounds as primary, secondary, tertiary halides. Okay, this is primary, secondary, so you have to draw that carbon structure, then you will see which is primary, secondary, tertiary. A compound A molecular formula is treated with depends upon the concentration of A only. So the concentration of the A only one concentration, that is SN, which SN1. Okay, this is the compound AAV compound. This is on 55. Write the structure of the names of the compounds formed with the compound A and the molecular formula is treated with the CLT in the presence of this. 56. Orthochlorotoluene, parachlorotoluene. Okay. Identify the products A and B on following reaction. 57. This one. One on the other side of the double bond. Okay. One here, one here. Which of the following will have the highest melting point and why? Due to the symmetry of the pair of positions, the crystal that is better than this. Already they given that answer, I think. 58. Write down the APC names of the neophentyl bromide. neopentyl bromide. The hydrocarbon of the molecular mass is a single monochloride derivative and the two dichloride derivatives of the photochloride give the structure of the hydrocarbon. 60. This is the one. Okay. #61. Name the alkane which will yield 1-chloro-1-methyl this by the reaction with the HCl. Write the reaction in 61. Okay. 62. Which of the following haloalkanes reacts with the aqueous OH most easily? Most easily. Tertiary carbocation formed in the reaction is stable. Okay. Why can HaloAlkane be prepared by the reaction with the phenol with the HCl in the presence of the zinc chloride? CO bond in phenol is more stable due to the resonance effect. Okay, the double bond character, hence breaking of the bond is difficult. The above method are preparation of the HaloAlkane because of the carbon action in phenols have partial double bond character and difficult to break. 64. Which of the following compounds undergo SN1 reaction faster and why? SN1 reaction faster and why? Due to the which has the resonance effect. Okay, this one will undergo the faster. 16. So answer 64. Because of the case of the two, the carbocation formed in the class of the is stabilized by the resonance. Allyl chloride is hydrolyzed more readily than the N-propyl chloride. 65. Allyl chloride shows high reactivity to the carbohydrate formed by the hydrolysis stabilized. Okay, you can go through this. Why is it necessary to avoid traces of moisture during the use of the Grignard reagent? 23. Grignard reagents are highly reactive and react with any trace of proton to give hydrocarbons and water. Okay, this is the answer. Therefore, necessary to avoid even trace of moisture in the Grignard reagent. Why do folate solvents help in this? So here polar protic solvents, so that it can break the ions, polarize. Here the polarized bonds. Write the test to detect the double bond in the molecule. 68. So you can go through this test in the net. The potential threat to the environment and how these are produced from the RL halides. So you can go through the net. 69. Maybe in the net you can search. What are the IUPAC names of the DTT and the, so 30. So here DTT you can go through this. Elimination reaction XB beta elimination are as common as the nucleophilic substitution reactions. Specify the reaction. Okay, 21. Beta elimination reactions you can go through. When haloalkane with beta hydrogen atoms treated with okay, you can go through how this elimination reaction takes place. The net you can go through this. Okay. RL halides are extremely less reactive towards nucleophilic substitution product and explain the order of reactivity of the following compound. Tertiary is greater than the second is greater than the primary. Now this will reactivity is more than this and this. Okay, these electron withdrawing groups. At butyl bromide reacts with aqueous SN1 mechanism while NPL SN2 mechanism. Why? 15. SN1 mechanism. 8 butyl bromide and the hydroxyl ion yields this one. Okay, the rate of the reaction. Okay, you can go through this. Already the major product then added HCl to the isobutylene. Explain the mechanism in 75. Okay, this one. This is 2-step. Discussing the CH bond in the HaloArenes. 76. Partial positive, partial negative. 77. How can you obtain the this form from the ethanol and no other iodine? 77. Cyanide acts as the ambident nucleophile, from which end it acts as the 78. Okay, you can go through this answer. Okay, this is to treat which disease. Okay, you can see these answers. Okay, typhoid, this disease, malaria, anesthetic, chloroform is anesthetic. Match the column 1, column 2. S and 1. Okay, this one. Chemicals in the extinguisher by extinguisher. Chloro, this one. Bromination of the alkenes. Okay, this one. Alkaline halides, halides. Elimination of the acids from the alkyl halide. Match the structure of the column given below with the column B. This one alkyl halide. This is halide halide. So it is connected to the carbon atom next to the double bond carbon atom. Okay. Directly connected to the benzene ring. This is connected to the double bond carbon atom. sp2 hybrids. So this is a double bond. 1 sigma and 1 pi bond. So you can go through this reaction. These answers you can go through it. Okay. So this is Fitty reaction means 2 aryl halides. Okay. Outside reaction and this reaction. So you can go through this. What is here? We are using two halides, 2 aryl halides. So here mixture of the alkyl halide and aryl halide. This is Sandmeyer's reaction. Phosphorus chlorides and are prepared over this 16. Sorry, 6. Okay, phosphorus halides. So is preferred than the phosphorus halide. The boiling point of the alkyls is decrease in the so actually so here the reason is not the correct explanation of the assertion. The boiling point of the alkyl, chloride, bromide and halides are considerably higher than the hydrocarbon, the comparable. Okay, so the reason is not the correct explanation of this boiling point. Okay. This is correct and this reason is wrong. So this is correct is also the correct explanation. Presence of the nitro group or the positions increase the reactivity of the, that is correct. Nitro group being the electron withdrawing group, decrease the electron, the correct explanation. In monochlorobenzene, this is correct, but this is not. The halogen atoms is a ring deactivator. This is not the correct explanation. Not this is ring deactivator is correct, but not the correct explanation for this. Okay, this is correct and this is wrong. This is the correct assertion, but it is a wrong explanation. This is wrong. Okay, this is wrong, and this is a empty rating group. This is correct. So this. So you can go use this hint to find the answer. Okay.